Okay, this is PreAlgebra 1. This is lesson 4.1, and it is on multiplying decimals. If you were using a base 10 pieces to multiply, and I have them on my desk so you can get them out and look at them if you want, we can use them to multiply and to understand how to multiply decimals. On step 1 here, how would you model 1 times 0.04? And that would be with 4 little pieces. In my box, they're yellow, not green. But step 2, how would you model 2 times 0.04? And again, we have 4 pieces twice. And in step 3, we say model 3.04 times 0.04, and that would be 3 sets of 4 here. It looks like I forgot one there. So multiplying with decimals, when you multiply a decimal and a whole number, the number of decimal places in the product is the same as the number of decimal places in the decimal factor. So let me give you an example. So let's look at this, and this is kind of hard to read because you can't see the dot, but this is 7 times 0.006, and so I rewrote it here in this box with the 0.0006 times 7. It doesn't line up really good using the program I was using here, but what you need to remember is that when you're multiplying it out, you got to keep the zeros. So let's look at it over here. Times 7. We have 42, carry the 4. 7 times 0 is 0, so we bring down the 4. 7 times 0 is 0. 7 times 0 is 0. And 7 times... Oh, I have too many zeros. Hang on. I just realized what I did. I erase it. Okay. Sorry, my pen's not working. 0. Now, it's important to realize that you have to keep these zeros here because they're placeholders. And we have 3 decimal places because we had 1, 2, 3 to get to that decimal place. 1, 2, 3. So you count the decimal places in the decimal factor to get how many decimal places you will have down here. So in this first problem, we have 3 times 0.005. We will multiply that, carry the 1. 3 times 0 is going to be 1. We have a 0, and we have a 0. We know we have 1, 2, 3 decimal places. 1, 2, 3. And our answer is 15 thousandths. It's thousandths because we have 3 decimal places. Okay, let's try another one here. Hang on. Try another one. Let's try 4. Let's try 0.024 times 4. And we have 8, 0, 0, 0. We count the decimal places. That's 1, 2, 3. 1, 2, 3. And that answer is going to be okay, I didn't write the right number down, so I apologize. It was supposed to be 0.024 times 4, and that's going to be 0.096. We have 3 decimal places, and so our answer is going to be 96 thousandths because we have the 3. So I didn't even spell it right up there. Okay, I'm on a roll here, aren't I? Okay, in this problem, we have 1.2 times 7. I can multiply my 7 times 2 is 14, carry the 1, 1 times 7 is 8. I have 1 decimal place, and so 1 decimal place is going to equal tenths, and so my answer is 84 tenths. I have 1 decimal place. Okay. Let's see, I don't know if I said this. 2.36 times 6 is the next one. So on this one we have, our answer is 14/16. We had 2 decimal places, so 2 decimal places equals hundredths. So our answer is 14.16 hundredths because we have 2. Here we just had 1 and it was a tenth. Say your answer was 106.08 and you're thinking, could I just eliminate the 0? No, you cannot, because 106 does, if the 0 was here you could, but not if it's before another number. You have to keep the zeros in unless they're at the very end once you're done. So let's look at solving a problem using decimals, and this is a picture of the Iditarod, and this is the junior race. And let's say that you had one team and they went for 18 hours. They did it over 2 days time period. They averaged 8.325 miles per hour. How long was the race? So let's see how we would set up this problem. So we need to use the formula distance equals rate times time. So we would write 8.325 times 18. We would multiply that out. We would have 0.0666, and then we would have 5, 2, 3, 8. Add that all together. We now need to figure out where our decimal place would be. We have 1, 2, 3 spots. 1, 2, 3 spots. So it's going to go right there. And now that we have our answer, we know that we can drop a 0, but we have already, we can't drop any zeros until we've placed it. And so this would be 149 and 850 thousandths. And we can round to the nearest mile. Okay, so I wrote this, I meant to put 8, it's 18 here, sorry. So I could round down. I could do 3 times 18. That's going to give me 54, and so I can say I'm in the ballpark. I'm not fun. That's a reasonable answer. Let's try another one. We have 12.706 thousandths times 3. The answer we got was 381.18 hundredths, and we now need to use estimation to see if we got a reasonable answer. So if I round this up to 13 times 3, I'm going to, so when I estimate, my answer is close here, so I know I'm doing right. I'm within the ballpark. That's what we're trying. Before I do the next problem, I'm going to go back up here to this problem because I rounded this down to 3 right here, but I could have done, if I wanted to, I mean, just 3.3 times 18, and I would have gotten 59.4, and now I can see that I am super close to what that answer was. So this one was simpler, and it got me, I can see I'm not far off, but if I really wasn't 100% comfortable, I could have rounded this up over here and gotten 59.4. So you can always estimate. If you're not sure, you know, you can try it again. So down here on the bottom we're going to have 15 times 4, which is going to equal 60, and we can see that 60 and 61 are really close, and so we can say that our answer was reasonable.